Hello everyone, welcome first year students English section, Faculty of Commerce, Salat City University. This is Reem Sobhi, I'm a teaching assistant at Insurance, Statistics and Mathematics Department. This is section 9 on pure mathematics course on chapter 4 titled Exponential and Logarithmic Equations. In this section, we hope to learn some objectives such as properties of exponents, what are the exponential equations, and the properties of logarithms, and what are the logarithmic equations. Properties of exponents and logarithms. For a, b, m, n be any real numbers and m is greater than 0 and n is greater than 0, we have the following properties. Property number 1, which is the multiplication rule or the multiplication property. If we have b to the power m and b to the power n and the two numbers are multiplied by each other, so we have the same base with different exponents, then this would equals to b to the power m plus n. So in the multiplication property, if we have the same base with different exponents, we should add the exponent with the same base. So b power m times b power n equals b power m plus n. Let's have an example. 2 to the power 3 times 2 to the power 4. We have here the same base, which is 2, but different exponents, 3 and 4. Then this would equals to 2, which is the same base, to the power 3 plus 4. And this equals to 2 power 7. So in the multiplication rule, if we have the same base but different exponents, we can take one number of these numbers as a base and add the exponents. The second rule, b power minus m. If we have a fraction here, 1 over b power m, we can raise the denominator to the numerator with a negative exponent or a negative sign of the exponent. So 1 over b power m or 1 over b all power m, we can raise b power m from the denominator to the numerator to be 1 times b power minus m. So raising the denominator to the numerator, this can be with a different sign to the exponent. For example, 2 power negative 3, this equals 1 over 2 power 3. This is the same. If we have a fraction and we want to raise the denominator to the numerator, we give the exponent a negative sign. And also, if we have a number with a negative sign in the exponent, this means this would be a fraction, or 1 over this number with a positive exponent or different sign of the exponent. Another example, if we have 5 power negative 4, this means 1 over 5 power 4. So negative sign for the exponent means this is a fraction. The third rule is the division rule, and if we have a number b power m over b power n, then this would equals to b power m minus n. So in the division, we subtract the exponent. In the multiplication, we add the exponent. For example, 5 to the power 4 over 5 to power 3, this means 5 to the power 4 minus 3. So in the division rule, we subtract the exponents if we have the same base with different exponents. But in the multiplication rule, we add the exponents if we have the same base with different exponents. Rule number 4, when we have b power m all power n, then we multiply the both exponents, the inner exponent with the outer exponent. So this would equals to m times n, b power m times n. For example, if we have 5 power 2 all power 3, this means 5 power 2 times 3, the inner exponents times the outside exponent. And this would equals to 5 power 6. Example 5, or property number 5, a times b all power m. We have different bases here, or different numbers multiplied with each other, but all with the same exponent. So different bases with same exponents. This is different from the previous properties that we have the same base with different exponents. But in property number 5, we have different bases, a and b, but they have the same exponent, which is m. So in this property, we distribute the exponents. So a power m times b power m. So in this property, we distribute the exponent n over a and b. For example, if we have 3 times 4, we have different bases here, but we have the same exponent, which is 2, all power 2. This means 3 power 2 times 4 power 2. So here we distribute the exponent. Property number 6. b power 0 equals 1. Any number power 0 equals 1. Property number 7. If we have b power x equals b power y, we have the same bases, then this means the exponents are equal. If we have the same base, b and b, but different exponents, this means that the exponent is equal. So x equals y. These are the properties of exponents. Let's take the properties of logarithms. Again, for a, b, m, n, x, y, and these are real numbers, and b, which is the base, does not equal 0. The logarithm of 1 for the base b equals 0. So the logarithm of 1 always equals to 0. Notice here we have 3 cases for the logarithm. The base of the logarithm may be equals to 10 or equals to b, which is a real number, or equals to e, and this is called a natural logarithm. And this equals to 2.7183. So the base of the logarithm can take 3 cases. The base can be 10, and this is the common base, or can be b, which is any real number, or can be e. But in this case, when the base of the logarithm equals to e, which is the natural logarithm, and equals to 2.7183, the logarithm transformed into len, not log. So len means the logarithm with natural base, or e, and this equals to len. So the first case, or the common logarithm base, which is log to the base 10, here we have some properties. The logarithm for 1 equals to 0 with the base 10, and in this case we don't write 10, and this means the base equals to 10. If we don't write the base for the logarithm, this means the base equals to 10. So the logarithm for 1 equals to 0, and the logarithm for 10 equals to 1, because the base of the logarithm is 10, so 10 for 10, this equals 1. When the base of the logarithm is the same of the number here, this means the logarithm equals to 1. The logarithm for 10 powers x, this means x log 10, which is the base for 10, and this, as we just said, this part equals to 1, so this equals to x. Also 10 power log x, this means this equals to 1, and 1 times x equals to x. This is the first case. Second case, when the base of the logarithm equals to b. Again, the logarithm for 1 equals to 0, and this is a standard case. Always the logarithm for 1 with any base, 10 or b or e, always equals to 0. And also the logarithm for b, when the base and the number of the logarithm are equal or are the same, this means the logarithm equals to 1. And this also standard or fixed for any type of base. And as you see here, the logarithm b with the base b for b, this equals 1. And the logarithm 10 for 10 equals 1. And the len for e equals 1. So when the base is the same as the number that we want to take the logarithm, equals to 1. The third case, the logarithm of b with b power x, this means the x or the exponent comes before the log, then logarithm b for b, and as we just said for the property number 2, log b for b, when the base and the number are the same, this means that this part equals to 1, so x times 1 equals to x. And again, for b power log b for x, this means b and the power goes with each other, and then x, this would equals to x. For the len, or for the natural base, when len 1 equals to 0, and also len e equals to 1, and these two properties are standards or fixed for all types of bases. Again, when len e power x, this means the x or the exponent or the power comes before the len or the log, then this equals to x len e. The power comes before the logarithm or the len. And as we just said in property number 2 here, that len e equals to 1. So x times 1 equals x. Also, when I said e power len x, then the logarithm goes with the base, and this would equals to x. Property number 5, when log b for x equals y, this means that x, the number, would equals to b, the base of the logarithm, to the power y. So when we said log b for x equals y, we can transform this shape into x power, the base of the logarithm, b power the other side of the logarithm, which is y. So this equals to x equals to b power y. And also for the 10, if I said log x for y, this means x equals, here base, the base is 10, so 10 power y. And here for this, for the third case of the bases, if I said len x equals to y, this means x equals to e power y, as the base here is e. The sixth property, when I said log b for n times n, we have two parts multiplied with each other, or two brackets multiplied with each other. This means log b plus log n, log m plus log n. So this is the product rule when the m is times n. We have two quantities multiplied with each other. Then we add the logarithm of each quantity. Property number 7, the quotient rule. When we have two quantities divided with each other, so we have log m over log n. This means log m minus log n. For any base, b or 10 or e, this rule is fixed for any base, any type of bases. Again, when I said log m power n, this means that the exponent comes before the logarithm, and a times log b for m. So these are the main properties or rules for logarithms. Let's have some examples to clarify these properties. Choose the correct answer for the exponential equations. Example, given the following exponential equation, the value of x equals, here is our equation, 169 to the power x equals to 13. This equation is called exponential equations, as we have exponents here and the exponent equals to x, and we would like to know the value of the x. We can use the properties of exponents. The first property said that when we have b powers x equals b powers y, then x equals to y. So we can make the base equals, and here we have the base 13 and 169, and we would like to equal the two bases. Then 169 means 13 power 2, so this would equals to 13 powers 2 all powers x. 13 powers 2 equals to 169, and this equals to 13. Then we have the same base here, but first for the left hand side we have two exponents, inside exponents and outside exponents, so we have to multiply the both exponents. Then 13 equals to 13 power 2x equals to 13, which that has the power of 1. Then we have the same base here, 13 equals to 13. Then the exponent of the bases are equals. Then 2x equals 1. This means x equals to half. And the right answer is A. Another example, given the following exponential equation, x power 7 equals to 1 over 49. The value of x is, we need to find the value of x here. First, we have to make the bases equals. So we have to transform 49 into 7, as 7 power x equals to 1 over 49 means 7 power 2. But 7 power 2 is in the denominator, and we want to raise this into the numerator, so we will give the exponent of the 7 a negative sign, and this would be equal 7 power x equals to 7 power minus 2. When we have the same base, then the exponents are equal, so x equals to minus 2. So the correct answer is C. Another example, given the following exponential equation, 5 power x squared minus 3, this equals to 5 power 2x. In this exponential equation, we have the same base, 5 and 5. So the exponents are equal. So x squared minus 3 equals to 2x. We have to transform this equation into the form of quadratic equation. So this would equals x squared minus 2x minus 3 equals 0. This is the form of quadratic equation, and we can solve this quadratic equation using factoring method. X, and 3 means 1 times 3. So we can give a positive sign here and negative sign here. Then the solution of this quadratic equation is x plus 1 times x minus 3, and this equals to 0. By equating each quantity with 0, then x plus 1 equals 0 and x minus 3 equals to 0. Then x equals minus 1 and x equals 3. So the solution set equals to minus 1 and 3. These are the values of x, and the correct answer is C. Another example, given the following exponential equation, 10 power x squared minus 8 equals to 100 power x. We have first to equate the bases. We have here the base for the left hand side equals to 10, and the base of the right hand side equals to 100. And 100 means 10 power 2. So 10 power x squared minus 8 equals 100 means 10 square, all power x. Then we should multiply the inside exponent with the outside exponent, and this equals 10x squared minus 8 is the same, equals to 10 power 2x. In this case, we have the same base here, so we can equate the exponents. So x squared minus 8 equals 2x. And again, we can use the form of quadratic equation. So x squared minus 2x minus 8 equals 0. And this, by using the factoring method, we can solve this equation with x and 4 and 2. As 2 times 4 gives 8, and the difference between 2 and 4 gives 2. And we can give the 4 a negative sign and 2 positive sign. So this equals to x minus 4 times x plus 2 equals to 0. So x minus 4 equals to 0 and x plus 2 equals to 0. So x equals to 4 and x equals to 2. So the solution set is 4 to minus 2, sorry. The solution set equals to minus 2 and 4. And the correct answer is B. Another example, given the following exponential equation, 2 over 3 to the power x plus 1 equals to 27 over 8. 27 over 8 means 3 over 2. Then, in order to solve this equation, we have to equate the bases of the both sides. Then the first, or the left hand side, equals to 2 over 3 all power x plus n, and the right hand side equals to 3 over 2. But in this form, the two bases are not equal. So we had to transform this factor into 2 over 3. So in order to get the reciprocal of this factor, we should give this factor a negative exponent equals to minus 1. So this would equals to 2 over 3 power x plus 1 equals to 2 over 3 power minus 1. Then we have the same bases here. After that, we can equate the exponent. So x plus 1 equals to minus 1. Then x equals to minus 2. And the correct answer is D. Another example, given the following exponential equation, 7 power 2x minus 5 equals to 7 power 3x minus 4. We have the same bases here with different exponents. Then 2x minus 5 equals to 3x minus 4. We can exchange this form into the form of the x's with in the left hand side and the constant in the right hand side. So 2x minus 3x equals, as we bring here 3x to the left hand side and minus 5 goes to the right hand side, so minus 4 plus 5. This equals to minus x equals to minus 1, so x equals to 1. Minus x equals to 1 and x equals to minus 1. And the correct answer is A. Example, given the following exponential equation, 3 power x squared minus 4x equals to 9 power x. Here the bases are not equal, so we should equate the bases first in order to equate the exponents. So 3 power x squared minus 4x equals to 9 means 3 power 2 all power x. So 3 power x squared minus 4x equals 2 times x, so 3 power 2x. In this step, the bases are equal, so the exponents are equal. So x squared minus 4x equals to 2x. We can bring this side or 2x into the left hand side. Then x squared minus 4x minus 2x equals to 0. So x squared minus 6x equals to 0. By dividing both sides with x, so x squared over x minus 6x over x equals 0 over x. This would equals to x minus 6 equals to 0, so x equals to 6. And the right answer is A. Another example, given the following exponential equation, 10 to the power x squared minus 1 equals to 1. Here the bases are not the same. The base for the left hand side equals to 10, but the base for the right hand side equals to 1, and these are not equal. So we should first equate the bases in order to solve the exponent. And for the left hand side, 10 equals to x squared minus 1. For the right hand side, 1 means 10 power 0. As any number, any real number power 0 equals to 1. So in this case, or in this step, we have the same bases, 10 and 10. so we can equate the exponent. So x squared minus 1 equals to 0. Then x squared equals to 1. By taking the square root for both sides, we get x equals to plus or minus 1. So the correct answer is B. Another example, given the following exponential equation, 10 power 2x minus 3 equals to 81. Find the value of x. In this equation, the bases are not the same for the both sides. And also we cannot equate the bases. We cannot make 81 equals to 10. In this case, when we cannot equate the bases of any exponential equation, we should use logarithm. So we will take the log for both sides or the logarithm for both sides. So log 10 power 2x minus 3 equals to log 81. And recalling the property of logarithm, which says that when we have a log for b powers x, this equals to x times log b. The exponent comes before the logarithm, and then this equals to x times log b. The same in this case, we can solve this as 2x minus 3 times log 10 equals to log 81. Again, recalling another property, when we have log 10 for the same base, which is 10, this means 1. So we have here the base here equals to 10. So log 10 for 10 equals to 1. And this would equals to 2x minus 3 equals to log 81. And we need only x in the left hand side and all the numbers in the right hand side, as we want to find the value of x. So 2x equals log 81 plus 3. Then x equals to log 81 plus 3 over 2, and this equals to 2.45. So the correct answer is A. Another example, given the following exponential equation, 2 power 2x minus 1 equals to 27. Again, we cannot make the base 27 equals to 2. So we will use the logarithm. So by taking the logarithm for both sides, we get log 2 power 3x minus 1 equals to log 27. And again, by recalling the property that says that log b power x means or equals x times log b. So we can solve this side by using this property. So 3x minus 1 times log 2 equals to log 27. And as we want x's only in the left hand side and the numbers on the right hand side to have the value of x, so this would equals to 3x minus 1 equals to log 27 over log 2. By taking 1 into the other side, this would equals to x log 27 over log 2 plus 1 all over 3, and this equals to 0.98. So the correct answer is A. Another example, given the following exponential equation, 3 times e power x minus 8 equals to 7. Find the value of x in the exponent. First, we have to simplify the shape of the equation in order to solve this equation and find the value of x. So 3e power x equals to 7 plus 8. We take 8 into the right hand side with different sign, so 3 times e power x equals to 15, and we can divide over 3 in order to simplify, so e power x equals 5. By dividing over 3 for both sides, we get e power x equals 5. And as you can see here, the base are not equal for the left hand side and the right hand side, so we should take the logarithm for both sides. But watch here, or note, when we take the logarithm for e, this means len, not log, so len e powers x equals to len 5. And again, by recalling the property that says that len e power x means x times len e. So this would equals to x times len e equals to len 5. And len e equals to 1. So this equals to x. So x equals len 5. And len 5 equals to 1.6. So the correct answer is A. Another example, given the following exponential equation, we need to find the value of x in the exponent. The first step is to simplify the form of the equation. So minus 2e power 0.1x equals to 1 minus 9, and this equals to minus 2e power 0.1x equals to minus 8. By dividing both sides over minus, this equals to 2e, so minus goes with minus, 2e power 0.1x equals to 8. We can divide over 2, so e power 0.1x equals to 4. But in this form, the bases are not the same, so we can take the log for both sides, and the log for e means len, so len e power 0.1x equals to len 4. And by recalling again the property that says that len e power x means x len e, and len e equals to 1, so this equals to x. So this quantity equals to 0.1 x len e equals to len 4, and this equals to 1, so 0.1 x equals to len 4, so x equals to len 4 over 0.1, so and this equals to 13.86, or we can say 14. So the correct answer is A. Another example, given the following exponential equation, e power 3x plus 4 equals to 22. Again, the base is not equal, as e is not equals to 22, and we cannot make 22 equals to e. So by taking the logarithm for both sides, we get ln e power 3x plus 4 equals ln 22. And again, by recalling the property, says ln e power x means x ln e, and ln e equals to 1, so this equals to x. So this quantity would equal 3x plus 4 times ln e equals ln 22, and this equals to 1, so 3x plus 4 equals to ln 22. And we need only x in the left hand side and all the numbers in the right hand side in order to get the value of x. So 3x equals ln 22 minus, we take 4 to the other side with negative sign, minus 4, and x equals ln 22 minus 4 over 3, and this equals to minus 0.3. And the correct answer is A. Thank you for watching this video and sharing your time with us. Hope it's useful to you. See you at the next video. Good luck to you all, and goodbye.